Yeah, welcome everyone to today's first session of the Munich Node user group event. And I'm going to talk a little bit about TypeScript and Node.js and how to combine both of them. And before we're going to start, I would like to point out that there is a chat available and a question and answer section. So if you have any questions in between, you can use both to ask. Maybe the preferred way would be to use the question and answers tool, because this makes it easier to mark to see which questions have not yet been answered and so on. But however, if you prefer the chat, feel free to use the chat as well. Okay, if you've seen a talk of me in the past, you know that I typically do a lot of live coding. Maybe you've seen it on Twitter. Yesterday I had also a live webcast running and my internet crashed entirely. And so today I'm hoping that everything will work fine. So far it looks good. And additionally, as said, the entire software is pretty much new to me. So right now I have several windows open by Zoom, and so I wanted to focus on one thing, and I didn't want to start interacting too much with different windows, and so I decided just to do some slides. And yeah, so a little bit different than my usual style, but I hope you can enjoy it anyway. Okay, so first of all, let's get started. And first, for those who don't know me, a few words about me. My name is Golo. I'm the founder and the CTO of The Native Web. We are a consulting, training, and development company located, as Christoph already said, in the southwest of Germany, near the frontier to Switzerland, near the frontier to France. And we basically care about web and cloud technologies, which of course means we deal with JavaScript and TypeScript. We do it in the backend with Node. We do it in the front end with React. And of course, if you deal with web and cloud technologies, it's not only about programming and developing, but also about the entire ecosystem and the infrastructure. So we also deal with Docker, Kubernetes, Git, and so on. And we have a few concepts and methods we focus on. And our main focus of interest is distributed architecture, primarily based on CQRS, event sourcing, DDD, then some AI, a little bit of cryptography, and agile, and so on. So this is basically what I deal with and who I am. And yeah, so, okay, let's get started with TypeScript. I suppose most of you use TypeScript, or at least know TypeScript. There's the option to, you can raise your hand virtually. So just out of interest, who of you uses TypeScript regularly? Can you please raise your hands? Okay, so yeah, this seems to be, yeah, two-thirds around, something like that. And yeah, okay, great, thanks. And now the big question is, okay, you can take your hands down again. I don't find the button right now. Okay, thanks. So most of you, or many of you already know and use TypeScript. For those who are completely new to TypeScript, just a very, very quick overview. TypeScript, basically in a nutshell, what is TypeScript? The official slogan is, I think, TypeScript is JavaScript that scales, because someone figured out that JavaScript is a great language for web and cloud development, but unfortunately, it gets difficult. It gives you extremely, option of freedom, and you can do amazing things with it as long as you are pretty much disciplined and know what you do. And the larger your team gets, the more difficult this becomes, because yeah, not everyone on the team knows what everyone else is doing, and maybe your interfaces aren't documented. And so it's actually Microsoft who designs and builds TypeScript. They had the idea, they have a big background in creating programming languages like Visual Basic, C#. I think these are the two they are most famous for. And actually the language designer who did design C# Anders Heilsberg, before he went to Microsoft, was the guy who created Delphi. And now, after his career with C#, he started his third, meanwhile, famous programming language, and this is TypeScript. And the core idea is that TypeScript is basically JavaScript with some superpowers. And basically, you have two highlights in TypeScript when you compare it to vanilla JavaScript. The first one is that you have, since you have a compiler, like with Babel example given, first of all, it's completely backwards compatible. So any JavaScript code is valid TypeScript code. But you can use very, very modern JavaScript language features, which in doubt get precompiled and downcompiled by the TypeScript compiler. You can even use future JavaScript language features because, hey, I mean, you've got a precompiler, so why not use it to already have a glimpse into the future? And you have a sophisticated static type system, and this is where the name TypeScript comes from. So essentially, Microsoft said, well, JavaScript is a great language, so let's make it a little bit better. And the biggest drawback of JavaScript, at least for some scenarios, is you don't have a static type system. And this is what especially lots of people who come from a C# or Java background miss. And so they added a static type system. And of course, if they just added a static type system, everyone would say, oh no, the dynamic type system in JavaScript was a really great idea. Why do we now have to use a static type system? And what's great about TypeScript is this is entirely optional. So you can use the static type system, but you don't have to. And if you use all these modern features, and if you use the type system, and if you use some of what TypeScript provides, like interfaces, like generics, and so on, this helps to better structure your code. And this is extremely interesting, of course, for solo developers, but especially for teams, because it can help to improve communication within a team. It helps you to coordinate work within a team. It fosters collaboration within a team. And well, as a bottom line, we can simply say TypeScript improves your efficiency as a development team. I myself, for those of you who know me, maybe you know that I have avoided TypeScript for years. Because I was a little bit afraid that it's another approach to, hey, we sell you a Microsoft product and then, whoa, you're caught and have a vendor lock-in. But meanwhile, I learned and I realized that maybe these doubts were a little bit, they were not really based on reasons, more on a gut feeling, and maybe this was wrong. So actually in summer 2019, I and our company re-evaluated TypeScript, and since then we've migrated our main product to TypeScript. We do lots of customer projects with TypeScript. Now we do a lot of consulting about TypeScript and so on. So and looking back today, I have to say I cannot imagine creating a larger web or cloud project without TypeScript. So this has dramatically changed the way how we work. So this in a nutshell is TypeScript. Now, basically, how do you use TypeScript? It's actually pretty easy. It's basically a three-step thing. The first thing is you need to install TypeScript. And since TypeScript itself, the compiler, is written in TypeScript, and TypeScript compiles down to JavaScript, the TypeScript compiler is just another NPM package like Express or React or Lodash or whatever you typically use as NPM dependencies. So installing TypeScript is as easy as running npm install TypeScript. The second thing you need to do is you need to create a small configuration file, the so-called tsconfig.json. And we will have a look at this in a minute. And once you have that, you can simply run the compiler. The compiler, in analogy to C#, the C# compiler is csc.exe for C# compiler.exe. And yeah, so TypeScript, the TypeScript compiler is TSC TypeScript compiler, and you can run it using npx. And that's basically it. And then you can use TypeScript. And the only thing you need to think about a little bit is this configuration file. And this configuration file, at first glance, it looks a little bit overwhelming, but in the end, it's pretty simple. I don't want to walk through all of these lines here. I just would like to point out a few of them. What's important maybe is this line with the output directory. So when you run TypeScript, it needs to know where to put the JavaScript files that it creates. You can define which JavaScript language version to use. So you can tell it to compile down to ES 2019 or to ES 2015 or to ES5, whatever you need. Maybe for the browser, you would like to have a more conservative choice. Maybe for Node, since Node using V8 is pretty much up to date, you may want to use a pretty late, pretty modern ECMAScript flavor or whatever. What's also interesting is the strict true setting, which turns the compiler into a so-called strict mode, where it very closely looks at what you are doing and complains about lots of things. But this is definitely reasonable to use this mode to ensure that you're writing clean code and you don't have strange things in your code that you don't want to have. So when you do TypeScript, turn on strict mode. That's a good idea. And last but not least, you have to tell the compiler which files to include into the build and which files to exclude. And of course, it makes sense. And in our project's example given, we always have a lib folder where the actual application code is residing. We have a test folder where the unit tests and the integration tests and so on are. And so basically, you want to you want to include these folders, but you want to exclude the build folder. Otherwise, you may end up with the TypeScript compiler trying to compile what it builds. So that's a little bit a dumb idea. So just make sure to exclude the build directory. Speaking from experience, that's just a good idea. Okay, so this is the tsconfig JSON file. And as said, once you have that, it's just an npx tsc, and you can use TypeScript, and that's it. So this is pretty much your quick start to TypeScript. Now, we would like to combine this with Node.js. And when we're talking about TypeScript and Node.js, the first question is, okay, how do these two things go together? I mean, the fact that TypeScript is being installed using NPM makes it pretty obvious how to use TypeScript with NPM, and you can run it by npx. But let's have a closer look. Basically, when you want to use TypeScript with Node.js, you have two options. The first option is you can have a separate compilation and execution step. So this means you write your code, and then you explicitly call npx tsc. So you compile your code into JavaScript, and then you run your JavaScript code. This works, of course. The other option, which I haven't told you yet that it exists, but let's just imagine it was there, would be to say, well, can't we teach Node itself to run TypeScript so that the separate compilation step is not needed? So we could call this compile while running the application. It's, if you want to say so, a little bit like a JIT compiler. So the question is, which of both options do you prefer? And yeah, well, if we look at the advantages and the disadvantages of both options, if you first compile down to JavaScript and then run, this means that in the end, you run JavaScript code, and Node doesn't care if this JavaScript code was generated or if this JavaScript code was written by you manually. So the performance, since no compilation is required at runtime, the performance, just a minute. I'm sorry. So the performance at runtime will be pretty good if you first compile and then execute. On the other hand, and this is the downside of this approach, this is pretty much annoying because whenever you change a file, you have to change it, you have to save it, you have to switch to the terminal, you have to run the compiler, you have to wait until it finishes, and then you can start running your application and checking to see that you've mistyped something. And this loop gets pretty complicated and lengthy, and it isn't fun anymore because this is what is so great in Node. Just type in a script, run node app.js, and it works. And you lose this with a separate compilation step. So if we were able to teach Node how to compile TypeScript At runtime, we wouldn't have this extra compilation step. So this would lead to a great simplicity at development time. On the other hand, since every code needs to be compiled at runtime over and over again, at least once when you start the application, performance suffers. So yeah, you have to choose. Do you want to have a great performance at runtime, or do you want to have simplicity at development time? And if we are honest, we want both. You typically want a great performance, at least in a production build. On the other hand, you don't want your production build to rely on a JIT compiler, at least not on TypeScript. On the other hand, you want a smooth and very, very simple development experience. So you don't want to have this manual compilation step every time. So typically you want both, simplicity while developing, performance when in production. So the question which now comes up is, I've said, let's suppose that it's possible to teach Node to run TypeScript natively. And the question is, can we do this? So how to compile TypeScript at runtime? And actually, of course, I mean, it's JavaScript. Of course it works. That's basically every time the same answer when anyone asks, is anything possible with JavaScript? The answer is almost with a probability of 1, yes. And which NPM module do you want to use for that? Yeah, so how to do this? There's actually an NPM module which enables this. And this NPM module is called TS-Node. And just the description of the module from the NPM side of it is, it's a TypeScript execution and REPL, so a read, evaluation, print loop for Node.js with source map support. So basically, this is an add-on for Node.js, which lets Node.js execute TypeScript code natively. This is not actually correct because it doesn't patch Node.js to understand TypeScript, but we'll talk about that in a minute. But the effect, it feels like now Node is capable of running TypeScript natively. How to use it? It's pretty simple. You install TypeScript as before using npm install TypeScript, and you install ts-node by running npm install ts-node. You create the configuration file, the tsconfig.json we already talked about. This is the very same file that we had before, so you don't need to do any adjustments for ts-node. Just use the same tsconfig file that you use for TypeScript. And finally, instead of running the compiler by calling npx tsc, you now run ts-node by calling npx ts-node appts. And this call replaces your typical Node app.js call. So by simply swapping Node for npx ts-node, you run TypeScript code instead of JavaScript code with Node, and that's it. And the point here is what ts-node does is, under the hood, it just takes your input file, and whenever a new file gets loaded, which means required or imported, whatever style you use, then this file gets run through the TSC compiler. So the very same thing happens under the hood as if you would run TSC manually. You just don't have to do it manually. So this is a convenience method. It's a shortcut method. And this is all that is needed to use TypeScript directly in Node without this additional compilation step. And this makes development very smooth. And when you're done, when you're happy with the result, you can still call npx tsc and compile your TypeScript code into JavaScript code, which you then are going to deploy. Okay, so this is basically how ts-node works. Now, running your code, writing your code, and running your code is only one side of the story. The other side is there are some additional infrastructure tools you may want to use, like you want to test your code or you want to do code analysis on your code. So it's not only Node, which needs to be able to deal with TypeScript. You also want, example given, Mocha to be able to deal with TypeScript, and you want ESLint maybe to be able to deal with TypeScript. And the question is whether this also is possible. And of course, since we're in the JavaScript universe, the answer is yes, of course it's possible. The only question is how. Actually, with Mocha, this is very, very simple. Because first of all, let's just pretend that Mocha knows how to run TypeScript. Actually, it doesn't, but just let's pretend that this for a minute. If it did know how to run TypeScript natively, this means you could write your code as usual, and you could write your tests as usual. You would just write them in TypeScript instead of JavaScript, and that's it. And this is exactly what you're going to do when you have a TypeScript application and you want to write your tests in TypeScript as well. Write them as if Mocha knew how to deal with TypeScript. Just do it. And the nice thing about Mocha, I'm focusing on Mocha here. Other test frameworks work in similar fashions. With Jest example given, this is in a similar way possible as well. I'm just using Mocha as an example here because I'm most familiar with Mocha. Mocha can actually integrate compilers, not only TypeScript, it can also integrate CoffeeScript or, oh, I've forgotten the name of this other scripting thing, but basically there's a CLI flag, which is -- require, which you can use to integrate other precompilers. And if you have installed TSNode, in the chat, someone just wrote, CoffeeScript, I missed that. I definitely don't miss it. But no worries, everyone has their own favorites. You have this -- require flag. And if you have installed the TSNode package, there is automatically also a TSNode/register package. And all you need to do to teach Mocha to be able to run tests written in TypeScript is that you have Mocha, blah, 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 your typical options, and then -- require TSNode/register. And this is just basically loading the TSNode package into the Mocha process, which then acts in the same way, like precompiling every file on demand as if you used TSNode directly when running your application. So this is basically the same mechanism. The point why you need to go this way is because we don't have a wrapper like TSNode for Mocha, something like TS-Mocha, but Mocha lets us inject a compiler using the -- require flag. And sometimes some people, this is a little bit advanced TypeScript, some people use a feature which is called path mapping. And this means that you can, in your tsconfig JSON, can define paths and redirect them to other paths. And if you use this, you also need to require tsconfig paths register. However, tsconfig paths is a separate module you need to install. But in the end, these are the steps that are required to run TypeScript with Mocha. To summarize, write your code as usual, write your tests as usual, and run Mocha with the additional -- require TSNode register parameter, and that's it. And then you have tests using TypeScript. So running Node with TypeScript and running, yes, this is correct. To answer the question from the chat, yes, other testing frameworks also allow the integration of compilers. Of course, you cannot say that for every single test framework out there, that may be more or less great support. But with Jest, there's, if I remember correctly, there's a plugin for Jest, which adds TypeScript support. So you're not tied to Mocha with this. It works with other frameworks as well. Okay, so this is basically how to run Node with TypeScript and how to, you're welcome, and how to run Mocha with TypeScript. So this was pretty easy. Now, you also typically want to analyze your code. And if you're coming from the JavaScript world, you may use JSHint or you may use ESLint. ESLint is the way more modern approach, of course. And so the question is how to teach ESLint to understand TypeScript. And here things get a little bit complicated because, yeah, well, you need a different parser for the language. ESLint first needs to understand the somewhat different syntax of TypeScript. And then, of course, you need TypeScript-specific rules because just being able to parse the syntax doesn't help you with anything except that ESLint at least is able to read the file, but you want to get some reasonable advice. And for this, you need specific rules that apply to TypeScript. And because this isn't that easy to implement, another company called Palantir had the idea, well, let's create, I don't know if if actually it's a fork of ESLint, let's call it the TypeScript version of ESLint. They developed a tool called TSLint. And this was meant as a replacement for ESLint if you're using a TypeScript, if you're doing a TypeScript project. The problem with TSLint was that now we had two tools that basically did the same thing, and which, you had doubled the support and the maintenance efforts, and well, it doesn't make too much sense. So the TSLint team did a really great job. TSLint was a fantastic tool by Palantir. However, over time, people realized that it would be way more usable and maybe also more reasonable to integrate TypeScript support into ESLint, because ESLint is basically the de facto standard for JavaScript and Node.js code analysis. And what's really great about ESLint is its extensibility. You can not only have custom rules, you can also have custom plugins, custom parsers, custom whatever you want to use. So you can customize it in a very, very great way. So people in the end had two challenges. First of all, as I already said, you need to teach ESLint to be able to parse and to understand TypeScript code, so that you don't, in the third line of your code, are being told by ESLint, well, unsupported syntax or something like that, or invalid syntax. And second, you need some TypeScript specific rules. And there, the TSLint team and the ESLint people worked together, and they came up with two packages. First, a parser, and second, a plugin with rules. So the first one is you need to install the parser if you want to use ESLint with TypeScript, which you can do simply using npm install @typescript-eslint/parser. And the second thing you need to install is you need the plugin so that you have some TypeScript specific rules, which you can do using npm install @typescript-eslint/eslint-plugin. And once you've installed these two things, basically you have all the components necessary to be able to run ESLint with TypeScript. However, you still need to enable the parser and the rules. For the parser, you typically have a .eslint config, RC config file, be it a JSON file, be it a JavaScript file. You can even do it in YAML. However, you have an ESLint config file, and there you have different sections, like you can have the parser options where you tell which JavaScript language version to use. You can define rules and so on. And there is one section which is, well, not so well known because many people don't need it actually. And this is the overrides section. And in the overrides section, you see that this is an array. You can add a number of override objects. In this case, we have one override object, but you could have multiple ones. And you can here say, well, for specific file types, I would like to override some of the settings of my ESLint configuration file, because maybe you have a project which uses JavaScript and TypeScript at the same time. So you don't want to turn your entire ESLint configuration to TypeScript, because then you would not be able anymore to use it with your JavaScript files. You want to have both at the same time. So the outer scope is your typical ESLint JavaScript configuration, and then inside of that file, you just add this overrides section and tell it, well, if ESLint happens to meet a TS file or a TSX file. A TS file, of course, is a TypeScript file. TSX, if you're doing React with TypeScript, then you have to deal with JSX, this fancy syntax of React. And typically in JavaScript, the file extension for JSX files is JSX. So in TypeScript, it's TSX. Normal TypeScript files and TypeScript React files. So for these two types of files, I would like to make some changes. And the first thing we are going to change is we are going to change the parser to use the TypeScript ESLint parser we just installed using the npm install command on the previous slide. And then all your TS and TSX files will not get parsed anymore by the default parser of ESLint, but using the TypeScript parser for ESLint, and suddenly ESLint will understand TypeScript. And then you also have to set some parser options because, example given, TypeScript typically uses import and export as keywords and not module exports and require. So you need to adjust the source type to module. And it's a very good idea to set the project path to the path of the tsconfig.json file so that ESLint know where to find the TypeScript settings. And then in your plugin section, you add the TypeScript ESLint plugin. And oh, by the way, this ... parser options and here the triple dot plugins means you can have other parser options and you can have other plugins as well. It's just that you need to add these things here. They don't need to be the sole settings here. You can have other too. And yeah, by adding a TypeScript ESLint plugin to the plugins list here, yeah, you tell ESLint, okay, there is another plugin which contains a set of rules for TypeScript. And basically now you have everything ready to parse and analyze TypeScript code using ESLint. And yeah, finally, you just need to tell ESLint which rules to apply. And this, again, is the typical rules section of an ESLint configuration file. We look at this in more detail on the next slide. I've just taken an excerpt here. And I would like to show you two types of rules. The first rule, this one here, is one that is completely new in TypeScript ESLint. This is the interface name prefix rule. If you have ever worked with C#, you may know that when you deal with interface in C# is always prefixed with an I, like an I enumerable or an I disposable or an I collection. This I is, it stands for interface, and in TypeScript, the rules are different. The TypeScript designers, which is Anders Heilsberg and his team, suggest not to use this prefix. And some people say, well, I would like to follow the advice of the, and I'll come to your question in a minute. Yes, of course, this happens when you read the chat and at the same time try to talk about something different. I first answered the question from the chat. Couldn't all that be done with extends? Basically, yes and no, because the thing here is that you still need to change, example given, the file extensions. And extends, it depends, yeah, as someone just wrote in the chat, it depends. It depends on how on how the rule set you extend from is configured. And if it has the right parser, then it works. But if you have it in a single file, your JavaScript definitions and your TypeScript definitions, you need to work with overrides. Then you can't use extends. Okay, so back to the rules. Yeah, and depending on whether you want to follow the advice of the compiler team of TypeScript to not use an I prefix, or if you say, well, I like the C# style, I actually would like to use an I as a prefix for my interfaces, there's now a rule for ESLint that you can configure, which is called interface name prefix. And you see that this is configured to be an error in this case, and we want never to have a prefix. You could also say always, and then you could, I think you could even specify which prefix. I'm not sure about that, but this is rule specific. And so you can see there are rules for TypeScript that are TypeScript specific and that do not make any sense in the JavaScript world, which are actually new to TypeScript. The other kind of rule is this rule here, TypeScript ESLint no extra semi. And as you can see in the line above, there is already a no extra semi rule in ESLint integrated. But there is, let's call it an advanced or an extended version of this rule, which is part of the TypeScript ESLint package, because in TypeScript, there are some places where you need semicolons or where you can use semicolons that you don't even have in JavaScript because TypeScript offers more syntax capabilities. So you need a more sophisticated no extra semi rule. And so the suggestion is, if you are in a TS or a TSX file, which we make sure because we are in the overrides block, then disable the no extra semi rule that maybe is enabled for JavaScript files, but enable the TypeScript specific no extra semi rule. So in the end, your rules section for TypeScript will have two types of rules: rules that are actually new to TypeScript and rules that also exist for JavaScript, but need a more sophisticated version to actually have the full power and the full options and possibilities for TypeScript. So, and then what's left to do is go to the ESLint documentation and go to the TypeScript ESLint documentation and look up the definitions of, well, 400, 500 rules in some, and to adjust your rules to the style you want to have. And this is basically how you can make ESLint work with TypeScript. And yeah, then you run ESLint as usual, and it works with JavaScript files and it works with TypeScript files. So what we now have is we have Node, we have TS Node to be able to have a smooth developer experience and directly run TypeScript with Node. We have TS Node register for Mocha so that we can write and run our tests in TypeScript. And we have TypeScript ESLint parser and the TypeScript ESLint rules plugin so that we can combine ESLint with TypeScript. And tests and code analysis are typically the two most important parts of the development ecosystem, where it's most important to turn them into TypeScript aware and TypeScript capable components. So as you've seen, I mean, I've been talking for half an hour now, but I was able in half an hour to tell you how to turn your entire tool chain to be TypeScript able, to be able to work with TypeScript. And if you just replay it in your head, it was just a bunch of npm installs. It was a few extensions to your ESLint config file, and it was the tsconfig JSON. That's, to be honest, not so much work, and it's actually pretty simple and pretty easy. So this is a really simple task. However, it can be even more simple, of course. So let's have a little bit of an outlook, what you can do to make this even more simple. And first of all, there is another npm module, which is called ESLint config ES. And this shameless plug, this is a module that we at the Native Web have written. And this is basically a plugin for ESLint, which has a strict ESLint, a super strict ESLint configuration for ES 2015 plus in TypeScript. And suppose you just have ESLint installed and nothing else right now, you install ESLint config ES by npm install ESLint config ES, and it comes with a number of batteries included, which first of all means it has a super strict rule set for ECMAScript, for vanilla JavaScript, because one of the main goals of us for this module was we wanted to make sure that code of two different developers looks the same, and that you can't tell from just looking at the code who has written the code. Of course, if we're talking about naming variables and things like that, of course, there are still different styles by different developers, but essentially you can at least lots of best practices and lots of styling issues, you can unify this very, very well. And this was the first thing. And ESLint config ES comes not only with the default, with all the rules of ESLint configured, it also has a few plugins for ESLint integrated, where there are some extended rules. So you can work with some plugins like the Unicorn plugin for ESLint by Sindre Sorhus, which is a great plugin. But you don't have to configure it manually. It's just there. If you install ESLint config ES, you automatically also get the plugin. And you also get the configuration for this plugin out of the box. You don't have to do anything for it. And ESLint config ES has additional rules for Mocha integrated, additional rules for React integrated, and even additional rules for TypeScript integrated. And you don't have to care about installing the parser and installing the TypeScript plugin. All you need to do to enable TypeScript support is install TypeScript. And if you have TypeScript, ESLint, and ESLint config ES, that's it. The same is, by the way, true for React. If you have installed React, ESLint, and ESLint config ES, React linting will work out of the box because ESLint config ES contains all the rules for React, and it contains a plugin which applies and which provides these ESLint rules. So if you want to have a very, very simple way of doing all this, check out this module. And if you're fans of very strict linting, then have a look at this module. I think it helps a lot. So first of all, as I already said, the rules are enabled automatically, also for TypeScript and Mocha if TypeScript is installed, or if, sorry, for TypeScript and React, with the only requirement you need to install TypeScript or you need to install React. So there is no need for additional installs. You don't have to care about all the plugins for ESLint, about the parser for TypeScript and so on. And you don't have to deal with all this additional configuration manually. ESLint config ES tries to intelligently figure out what you want to do by looking at what packages you have installed and tries to do the correct things. All of this is described in more detail in the documentation. And as said, if you want to check this out. And then coming back to the question with extents, using this plugin is really, really simple because in your ESLint RC file, you only have to have one line, which is extents es/node if you're working with Node.js, or extents es-browser if you're doing client-side development. And you can forget all this with overrides and parser options. ESLint ES, ESLint config ES does all this for you under the hood automatically, correctly depending on your project scenario. So this is the simplest way to set up your ESLint rules. If you now also say, well, okay, this is great, but maybe I would like to also use this for tests, and maybe I would be more interested in an even more integrated development experience. There is another module which I would like to recommend, which has also been created by us. It's called Roboter, the German word for robot. Actually, I think it's a Russian word, which is basically our highly opinionated build tool for JavaScript and TypeScript. And then you can forget about installing ESLint. You don't need to install TypeScript anymore. You don't need to install ESLint config ES anymore. The only development dependency you have to install is Roboter, and then you can call it using npx Roboter. And if you, example given, if you want to run your tests, you say npx Roboter test. It only runs your tests. If you want to say analyze my code, you say npx Roboter analyze, and then yeah, you get all this for free. And if you have a tsconfig JSON file, Roboter will work with TypeScript and will configure ESLint automatically correctly for you, and it will correctly configure Mocha for you. If you don't have a tsconfig JSON file, then it will assume that you're using vanilla JavaScript. So this makes it extremely easy. And we are using Roboter for around 300 NPM modules and applications that we've written. And the big advantage of having a highly opinionated build tool, which actually allows for zero configuration, is that all your modules and all your applications have the very same structure, and you don't have to think about how to structure things, and it gives you guidelines, and it lets you focus on what's really important. So this is basically what Roboter is about. So if you're curious, check it out. And yeah, so in the end, this is basically what you need to do to make Node and TypeScript work together. Yeah, as I pointed out in the beginning, we do more than this. As I said, we do consulting, training, and development. We do it remote and on-site. I mentioned the technologies we work with. I mentioned the concepts we work with. And this basically is the end of my little talk today. And yeah, so thanks a lot for attending. I hope you liked it and there was some news for you. And yeah, have great success and fun with TypeScript, and stay healthy. And yeah, the most important question of all, are there any questions? And Christoph is there as well again.